people and welcome. In today's video, we are talking about radical expressions and rational exponents. Okay, radical expressions, anything that's a radical means it has a root, cube root, fourth root, fifth root, eighth root. Doesn't matter what the root is, it just means it has a root, square root. Rational, we already know what rational means. Rational means fraction. So a rational exponent means there's a fraction in the exponent. Now, what we're going to do is we're going to translate radical expressions into rational exponential expressions and vice versa. So what we need to know is this, and I kind of took the liberty of writing this out beforehand. When you have a radical expression, when you have a root of something, what that means is you have that root and inside of it is stuff in bubbles. So in this case, our a is in a bubble. The exponent of a in this case is m. The root is n. And so when we rewrite it into a rational exponent, m is over n. So n is your root. M is the exponent. M is the exponent, n is your root. So when we rewrite it from a radical expression to a rational exponent, you need to make sure that you have that correct. All right, before I actually do these examples with you, I'm going to zoom this out and show you the rules for exponents. Now, these rules are going to come in handy when you're simplifying expressions, especially radical expressions. You're going to always, when you're dealing with radical expressions, you're always going to convert them to rational exponents. It's so much easier to deal with radical expressions when you can convert those to fractions in your exponent. Now, when you are converting fractions, when you are converting radicals to rational expressions, then exponents, rational exponents. That is a tongue twister. You guys, I apologize. I will promise you that I will mess up again and again when I'm saying those two words. But when we are just translating that from a radical to an fractional exponent, the exponent rules all apply, and we have to know what those exponent rules. So I'm just going to briefly go over it. What I recommend is either taking a picture of this, always having this present. Google is fantastic. So if you type into Google exponent rules PDF, there will be plenty of PDFs for you to print out that look a lot better than mine. I just wanted to briefly go over it in my video. So the product rule is if you have the same base, the exponents are added when you are multiplying those two terms together. If you have the same base and you are dividing, then you are subtracting the exponents. When you have a base and an exponent, and all of that is being raised to a power, that means your exponents are being multiplied. When you have two different bases being multiplied and they are being raised to a power, you are unofficially, this is called the power of a product rule. In my class, we are unofficially going to distribute. Now, we don't actually say this outside of my class, but we're going to take that x, we're going to go put it on every single term that is on the inside. Same thing with division. You're going to take that x, you're going to put it on every single term that is on the inside. It doesn't matter how many terms you have, you just go ahead and keep putting that on the inside. And that is the power of a fraction. Zero exponent, we all know that anything raised to the zero power is 1. It's really cool to prove that. So if you want to, go to YouTube and just say proving zero exponent rule, then, it's a really interesting proof. Negative exponents, if you have a negative exponent, just know that that negative disappears once you put the entire thing in the denominator. The negative just means, hey, put all of me inside of the denominator. And the last one we have is the fractional exponent. So that's what we're doing when we're when we're translating your radical into a rational exponent. And that is whenever you have, and you can go one or the way or the other, make sure that you have your exponent m on top of your root n. All right, beautiful people. I mean, once again, before I jump into these examples, I want you to memorize this. It always confuses me which one's M, which one's N, especially since we just finished talking about the rational root theorem where we as well used M and N. So the easiest way to remember the translation is remember square root. So when we have a square root, here's your square root. This is what we usually see. We usually see a square root. And we're thinking, like, for example, the square root of 4. Well, what is the square root of 4? The square root of 4 is 2. So how did we get to 2? Well, what happened is we have an exponent here of 1. Anything that's inside has an exponent of 1. This has a secret 2 in it. So what I truly have is 4 to the 1/2 power. And 4 to the 1/2 power is 2. Now, keep in mind whenever you're simplifying these, I think I mentioned it when we were solving equations. When you are solving equations, okay, here it is, solving equations, and you have something like x is equal to, let's do x squared is equal to 4. We're going to take the square root of both sides, and that is x is plus or minus 2. That is different than simplifying radical expressions. Whenever you're simplifying, you do not have a plus or minus. You don't have a plus or minus because you're not solving for x. You're just saying, what's the square root of 4? Square root of 4 is 2. It's always the positive. Okay, so just make sure that it's plus or minus when you're solving equations. It's only positive when you're simplifying expressions. Now, expressions don't have an equals. This one, equation, has an equals. When you're solving for a variable, it is a plus or minus. If you are not solving for a variable, you don't have a plus or minus. Hopefully that clarifies some things. All right, so make sure you remember square root is 1/2 for your exponent. And if you do that, anytime you do that, square root is 1/2, it will make sense and you can use that as a reference. All right, let's go ahead and jump into here. So this is asking us to translate radical expressions into expressions with rational exponents and vice versa. All right, so what we're going to do is, here is our base. Anything that is raised to the power is our base. So we have a base of negative 125. And I'm going to keep it in a bubble on the inside. For example, here we have x as our base. And I'm, again, putting that base in a bubble. It matters. Now, what is the exponent inside for the bubble and what is the root? How do you remember that? That's where you can use your square root as a reference point. You always know when you take the square root that your root is 2. You're taking the square root. 2 is your root. The exponent for the bubble is 1. So then you know that this is going to be your exponent. This is going to be your root. So then looking here, the top one's going to be your exponent. The bottom's going to be your root. So your exponent is 4. So I'm going to write a 4. The bubble is raised to the fourth power. The root is 3. So exponent is 4. The root is 3. Now I'm not going to go ahead and fully simplify these. If some of them can be, I just want to show you how to translate them. Simplifying will come next. All right, same thing. I'm looking at my reference of 1/2. This is my exponent. This is my root. So that means what do we have? We have exponent of 11, root of 8. All right, now let's go backwards. And again, I'm using this, my 1/2, my square root, as a reference. Inside, I know that 1 is my exponent, 2 is my root. Then how would that look like in a fraction? The exponent goes on top, the root goes on the bottom. So put your base in a bubble. So your base is 6, your exponent is 4, your root is 5. All right, let's do that again. Here is negative 32, 243. Oh, okay. This is where you're going to need to use your exponent rules. I have a fraction being raised to an exponent. So what's my fraction being raised to an exponent? Here it is, power of a function. If you have a fraction being raised to the exponent, that exponent goes on both terms. So what I really have here is I have a negative 32. You can do the negative anywhere you want, but you can do negative 32. I'll leave it to the outside of 2/5, and I have 243 2/5. Now you can put the negative, out in front. That's fine. So what do we have? Here's your exponent. Here's your root. So I have the 5th root of 32 squared, and I have the 5th root of 243 squared. Now this, again, we can go backwards. We can also say, I'm kind of running out of room here, but we can also say that we can have the 5th root of 32 over 243, squared. And you can simplify that if you want. You can simplify. I know that one can be simplified. All right, let's go ahead and do just a few more examples. Again, we're just translating these. Simplify if you can. So we have y is equal to, what's my exponent? 5. My root is 7. Here we have our bubble is negative 332. Again, so we're writing it as a 5th root of negative 32 cubed. And here we have, we are given a root, so we don't need a root. We need to write it as a rational exponent. So here's my base, 4 over x to the 9th power, and my root is 3. Another way you can think about it is always exponents always go on top. So whenever your base is, your exponent is going on top. Whatever your base is, your exponent is going on top. So the top number is always going to be your exponent. Your exponent goes on top. We can actually write that out if you want to. I would suggest doing that in a thinking bubble. All right, beautiful people, that's it. We're just going and translating. We're going to do more examples in class on how to simplify these even further. As always, thank you so much for watching my video, and I will see you in my next one.